Hi everyone. Today's practical walkthrough focuses on a key skill in your SPA, collecting accurate mass data, applying mole calculations, and identifying unknowns. This practical is commonly tested in Paper 3, and it develops skills in data analysis, interpretation, and evaluating chemical changes. Let's get into it. By the end of this practical, you should be able to accurately record masses using a balance, use mole ratios to calculate amount of reactant, determine purity of a sample, and use qualitative analysis to identify ions. Remember that these are core assessment skills for both practical and theory papers. Let's take a minute to recap the instructions. Read carefully. Part A, Part 1I. Question tests your ability to record 3 sets of mass readings correctly and calculate mass differences in Part 2 later. In the space provided, you should record your results in an organized manner. You can either list down all 3 masses clearly or you can draw a table to tabulate your results. Personally, I prefer the table format. Note that 1 mark is allocated for presenting data to nearest 0.01 gram and with correct units. And the reading recorded with appropriate header or statement for mass of an empty test tube, mass of test tube and its contents before heating and mass of test tube and its contents after heating worths 1 mark each. Next, Part 2 requires you to calculate the mass of R and difference in mass correctly in 2 decimal places and with correct unit. Pause, the data which you had recorded may vary from mine. It's okay. But I will continue to answer question Part B with my set of data. When you do corrections, you should take reference from your experimental results. This part tests your understanding of mole concept. Given from the previous part, my calculated change in mass is 0.40 gram. This change in mass is due to the mass loss when carbon dioxide and water escaped upon thermal decomposition. The sum of molar mass of carbon dioxide and water is 62 gram per mole. To find the number of mole of carbon dioxide and water, I will take 0.40 divide by 62, and attain 0.00645 moles according to the equation, see page 1 introduction. For every 1 mole of carbon dioxide and water lost, 2 moles of sodium hydrogencarbonate is decomposed. So, moles of sodium hydrogencarbonate is twice the amount. Hence, taking mole times molar mass, my calculated mass of sodium hydrogencarbonate is 1.08 gram. Remember to keep your final calculated answers in 3 significant figures with the correct unit. Alternatively, there is a different way to solve the question. You may pause here to take time and understand this alternative method. Here, we need to recall that percentage of purity can be calculated by taking mass of pure sodium hydrogencarbonate divide by the mass of R times 100%. Substituting my answer from Part B, 2, and the weighted mass of R in Part A, 2, in the formula, I got my answer to be 72.3%. Again, the final answer must be in 3 significant figures. Next, suggest why heating the sample once for 3 minutes may not give an accurate value. This is because, not all sodium hydrogencarbonate NR is decomposed to form sodium carbonate in 3 minutes of heating. Time may be too short. Then, suggest a way to improve and obtain a more accurate value. I suggest to heat the solid repeatedly until a constant mass is obtained. When all sodium hydrogencarbonate decompose to sodium carbonate, which is heat stable, then there should not be any further loss of mass. Question Part D. Onwards investigate on solid S, which is the remaining product after decomposing R by heating. You have been reminded to test and name any gas evolved. Part D stated that dilute nitric acid is added to S, a little at a time until no further changes. You should observe that S dissolved in nitric acid to form a colorless solution. Effervescence of colorless and odorless gas was produced. The gas forms white precipitate in lime water. This confirms that carbon dioxide gas is produced. Part E, I, taking a portion of solution from D, and add a few drops of aqueous silver nitrate. This test for presence of chloride ions. White precipitate is formed. Thus, chloride ions are present in the sample. Part E2, taking another portion of solution from D, and add a few drops of aqueous barium nitrate. This test for sulfate ion. There is no visible change. This tells us that sulfate ions are not present in the sample. Part F needs you to identify the impurity in R. After reading the introduction on page 1 carefully, you should know that the impurity present in R is another sodium compound which is unaffected by heating. And after QA test for anions, what can you tell? Yes, you are right. The impurity is sodium chloride. I hope you recalled that sodium chloride is heat stable and does not thermally decompose on heating. This comes to the end of our practical debrief. Thank you very much. Bye.